So there's a couple of things we also know in terms of that elliptical motion. If we go back up here, we know that at half point, at half the time it actually takes to get to the end, it will get not only a maximum height in the y component, in the vertical component, but the velocity in the y component will also be 0. So if we use, okay, so I'll just put that in. So let's say at half, so at t half, at halfway through its trip, there's a couple of things that we know. So at half t, the displacement in the y direction is going to be at its maximum, and the final velocity in the y direction is going to be 0 meters per second. So if we use our Vy equals u in the y direction plus a in the y direction t, because remember time doesn't have a direction, it's a scalar quantity, we can plug those values in. So we have, let's put our our v in orange, which is 0. So at, let's finish this off. So at t half, halfway through the trip, at t half, the initial velocity is going to be, the final velocity, sorry, is going to be 0 meters per second. Okay, will equal our initial velocity. So our initial velocity was 5 meters per second in the y direction, so in the vertical direction is going to be, our initial is 5 meters per second. Okay, and I'm already going to take away, because remember our acceleration, so that should have been green, our acceleration due to gravity in the y direction is 9.8 meters per second, right? And multiply that at halfway through, the time at half. If we bring that over, that's going to be -5 meters per second is going to equal -9.8 t half, 9.8 meters per second t purple t half. So in order to get our t half, so the time at halfway, it's going to be our -5 meters per second. And I'm going to do a little bit of cancellation here in terms of our actual units. So this particular part is not wholly necessary as long as you maintain the unit correct at the end, but I'm going to show you a little bit of something quite interesting. So to the ms to the -1, so if we divide that by -9.8, okay, and here the units are in meters per second, okay, so our like terms are going, so first off here, these two will cancel each other out, so you're going to get a positive value, which is, so 5 divided by 9.8 is actually 0, so our time at half is going to be 0.51. Okay, so here's how we actually figure out the we know that time is in seconds, but here you'll find something very intuitive here. When you actually maintain the units, the like terms cancel each other out, so meters will cancel out meters, and you have seconds to the -2 here, which actually is the same as seconds to the -1 times seconds to the -1, which is the same here as seconds to the -2. Here we have like terms, so one of these will get eliminated, and you're left with seconds to the -1. Seconds to the -1 is the same as 1 over seconds. If you divide that, it actually inverts. So this actually comes to the top here and just becomes seconds to the 1. So seconds to the 1 is just the normal unit, so 0.51 seconds. That's just something on how to solve for the units. when you do a little bit more complex physics later on, it becomes a bit more intuitive in actually having how to solve that. Awesome. So we've got our time at halfway point. So if that time at halfway is 0.51, then our total time should equal, now just double that, which is 1.02. 1.02 seconds. That's how long it will take for the whole complete motion. So let's have a look at this particular time, at time half. We know that the displacement in the y direction will be maximum. So displacement equals u y t. Okay, let's do this in colors as well. I'm sorry, it's going to be a little bit slow. U y at t half, and I'll already put a minus here because it's going to be minus, because it's usually plus half at squared. So I'm already going to do here minus our acceleration in the y direction divided by 2. So remember, half a, and then multiply that by t half squared. So if we plug in these values, the maximum displacement is going to be our 5 meters per second multiplied by t half, which is 0.51. Take away 4.9, because remember our acceleration in the y direction is 9.8. Taking away 4.9 times, and let's put it in purple, times 0.51 squared. And if you do those values, they should equal to, I believe, about 1.27, right? No, 1.28. 1.28 meters. So in the vertical direction, so if we go all the way back to the top, at this point here, it will be at 1.28 meters high. So just to finish off, because this video is getting very, very long, I apologize for the length once again. We want to find out how far it actually went. So this one's quite intuitive. So if we know that in the x direction, the velocity is constant, so velocity in the x direction, if we know that is constant, then we can use the very first equation that we get, which is just going to be the displacement in the x direction over the time. So here, the full time, which is very simple. Our velocity in the x direction we found was 8.66. Let's have a look up here. 8.66 meters per second. It stays constant the whole time. So 8.66 meters per second equals our displacement in the x direction divided by our full time, which is 1.02 seconds. So in order to get our displacement, it's very simple. Our displacement in the x direction is just, and here I'm going to do also one more thing. I'm going to do another solve of the units. So here you see the units that I've kept. So it's going to be 8.66 meters per second to the -1 times, in purple, times our 1.02 seconds. This is the same as seconds to the -1. Seconds to the 1. If you multiply that by the -1, okay, they will just add to each other. So 1 plus 1, they eliminate. What unit are you left with? Meters. Oh my god, you're left with meters. So the final the final displacement is going to be 8.66 times 1.02. So I'll do that quickly. 8.66, oops, 0.66 times 1.02, we should equal 8.83 meters in the x direction. So its final displacement, because remember there's no longer any displacement in the horizontal direction, it will have landed in the same plane. So its final displacement is going to be 8.83 meters. So this was a really long video, so hopefully you found that one helpful, and I'll see you guys in the next video.